looking at the first example, the idea, again, the goal is to cancel one of the variables. All right. So what I want to be able to do is look at my two variables. I got x's and I got y's. All right. I want to be able to cancel one of them. One of those variables has to go. All right. The idea is that I need to be able to cancel them when I add the two equations together. So the operation that we're gonna use here is addition. We're gonna add the two equations. All right, so those two equations are gonna get added together. If I were to, let me just play this out right now. If I were to add these two equations as they currently are, I wouldn't get any cancellation. So don't write this down just yet. But let me just show you what would play out. All right, I would have 2x plus 1x, which would be 3x. I'd have y plus negative 3y, so 1y minus 3y, which would be negative 2y. And then I'd have a negative 5. All right, you'd add down the columns. All right, any like terms get added together. The problem is that didn't do what we needed it to do. It didn't cancel any of the variables. All right. So that's where the modification comes into play. I need to be able to have a cancellation of the variable. I need one of these to go away. I need either this to become a 0x or this to become a 0x. All right. So what I want to do instead is see if I can make it so that the coefficients of one of the variables, let's say the x, for example. I could have said the y, but I'm going to say the x. All right. I want the coefficients of one of the variables to be opposites of one another. In fact, I'll do it both ways just so you could see. All right. So I'm going to actually, you know what? I'll do a copy paste just so it looks a little bit more professional. Take a screenshot, copy, paste. All right. So I'll show you both ways. All right. So I want these coefficients to be opposites of one another. So what I can do is I could use a property of equality, multiplication, to guarantee that that's the case. All right. If I multiply, for example, the second equation by just the number 2, that'll get me close, but not quite there. All right. Let me just show you. Again, I'm going to carry out the process and show you why it doesn't work, and then show you the correction. All right. So don't write this down just yet. All right. So if I multiply the second equation by a 2, the first equation, I'm not doing anything to that. The second equation would become 2x minus 6y equals negative 22. All right. If I were to add these two equations together, I still don't have what I'm looking for, because this would become a 4x minus 5y equals negative 16. All right. I still didn't get that cancellation, so this is no good. However, if I multiply, instead of by a 2, if I multiply by a negative 2, now I'm on to something. Because my first equation would have a 2x plus y equals 6. My second equation now has a leading coefficient of negative 2x. If I run through with that negative 2, I'd have a plus 6y is equal to positive 22. Now when I add my two equations together, 2x plus negative 2x gives me a 0x. 1y plus 6y, see I gave it away, is equal to 7y. Not that there was much to give away, but you know what I mean. And then 6 plus 22 is 28. So this is the same as saying 7y is equal to 28. Now I'm just one property of equality away from having my answer, at least for the y part of it. All I'd have to do is divide both sides by 7. And I get a y is equal to a 4. All right. So just by choosing the most appropriate value I was able to guarantee that I would get a cancellation. Now, we're going to learn how we choose that most appropriate value. That's going to be the key.
I'm confused. Why are we adding the two together? Like
the two equations?
Yeah.
Oh, that's the elimination method. That's the technique that we're using.
Okay.
It's just a process. Yeah. So you could always, if you want to get equality, you could always add two equations together to get a third equation. That's a valid operation involving equations. All right. So, yeah.
How did you get the -2? Do you just get to choose the number?
Well, that's the thing. At this point, we're just saying it's like guess and check, but I'm going to show you a different technique in a minute.
Oh, okay.
Yeah, so let me carry out the rest of the process, and then I'll show you the real way to come up with that -2.
Okay.
So 2x plus y is equal to 6. All right, just like substitution, once you figure out one of the two variables, we then choose one of the two equations. You go back to where we started, choose one of the two original equations. We now know that y is equal to a 4. So I can replace the y in my equation with a 4 and solve. Using properties of equality, subtract the 4 from both sides. Using another property of equality, division this time, divide both sides by 2, and you get x is equal to 1, which gives the solution of 1, 4. All right. Yeah.
If none of the numbers are multiples of another number, so would you do the for in this example -2 on both equations if there is no.
That's what I'm going to get to. Yeah. That's the trick that's coming up in a second. It's a calculator trick, so that's why I'm kind of holding off on it. So when we get to the more interesting case, which is coming right up, just hang on a sec, folks. It's coming right up. Just let me get through this example, and I'll show you. I'll show you all that you wish to see. All right. So the other possibility is we could have gone from the beginning and looked at the same system of equations, but then you might have said, you know what? Instead of getting rid of the x variable, maybe I want to get rid of the y variable. All right. So if you're looking at the y variable, you might say, all right, well, what's it going to take to get these two to cancel out? You'd look at the y coefficient in the first equation as being a 1. If only that 1 were a 3, then it would be perfect. All right, so what we would do is we would multiply our first equation by a 3. So in this case, we would get 6x plus 3y is equal to 18. Leave the second one the way it is. X minus 3y is equal to negative 11. All right. Yeah.
So you basically just make it so that whatever, if there's 4x on one side, you need negative 4x on the other.
Right. Yeah. Exactly. Yeah. Opposite coefficients.
You can just do that. There's no justification. You don't need to
Well, that's what I'm getting to. Yeah. So if you add the two equations together, you get a 7x is equal to a 7. I'm going to divide both sides by 7. And you get x is equal to a 1. All right? So that's consistent with what we did using the other method. Then I would choose one of the two original equations, whichever one you prefer. All right? So it doesn't matter. I'll take the 2x plus y equals 6. I'm going to replace the x with a 1. And solve. So 2 plus y is equal to 6. I'm going to divide, or in this case, I'm going to subtract a 2 from both sides. And I get y is equal to 4. All right, so same solution, different avenue. All right, we took a different beginning approach, but it still worked out the same way. All right. So now we'll work on a situation where it's not quite as clean, where you can't just kind of guess and check your way into the answer. All right. So the thing is, folks, you got to be careful. I know some of us kind of wanted me to get there a little quicker, but the problem is I can't. You know, like if you're ready to move on to the more challenging problems, I know that's good, but there are some of us that aren't ready, and I need to build the process up for those folks. Otherwise, they're kind of lost in the weeds. So I want to make sure that everybody's on the same page. So I know there's the, like the, just tell me how the story ends. But then you just got to kind of think of it as like you're reading a mystery novel. You don't want to spoil the ending for some folks. So let me grab a nice funky one for you, one that's not quite so clean. So how about number 3 on page 15? That's probably the one when you go through stuff like this and you look for the hard one. That's probably the one that jumps out at you. All right. So what you need to do again is come up with a value or set of values in this case that would allow you to cancel a variable. All right, you get to decide which variable you want to cancel, although sometimes it's very obvious which variable should be canceled. All right, and your experiences with this will dictate whether or not you're able to recognize those instances. All right, but here you see a 3 and a 4 for the x's, and you see a 2 and a 7 for the y's, and you think, all right, I don't know, let's try to cancel the x's, I guess. I don't know. They both look equally unpleasant. All right. So what we need to do is find the LCM between the two coefficients. All right, so find the LCM between the two coefficients. Remember, LCM, same idea as least common denominator, LCD. The exception being that it's not necessarily a denominator. As you can see here, these aren't fractions. All right, multiply each equation by a value to make your coefficient into the LCM. All right. Now this is a key fact. One coefficient must be positive, the other must be negative. All right. So you have to make sure that that's the case. And the way that you would handle that is by multiplying an equation by a negative. But it depends on which equation you want to make negative. So I would say multiply equations by -1 as needed. All right, that's where the number sense comes into play. You kind of look at it and say, all right, well, I'd prefer this one to be negative. This one I'd rather be positive, so I'll negate this equation. I'll multiply this one by -1. All right. So find the LCM between the two coefficients. Remember, the calculator can do that for you. I'll show you. All right, both calculators. I'll actually show you on both. If you have the TI. Multiply each equation by a value to make the coefficient into the LCM. One coefficient must be positive, the other must be negative. So you multiply your equations by -1 as needed. All right. Now, before I get into the solution here, I will address the one question that always comes up. Why on earth do we have to do it this way when the other way works just so beautifully, the substitution method? Can't we just use substitution? Well, you know what? I'm just going to use substitution all the time. I'm not even going to do it this way. So no, and no. You have to be able to do it this way because, one, it's required. They're going to ask you to do it this way on the regions. I'm going to ask you to do it this way on the test, so you don't have a choice. All right. But also in future years, I mean, a lot of my explanations come down to in the future you're going to be expected to do it this way, but that there will be a branching off point in where you go academically. You know, it's not quite like the old European system where it's like in 8th grade you take a test and that just determines whether you get to go to high school at all. I don't think it's like that anymore, but it used to be like you go to high school or you go to trade school. Like you take the test. If you don't pass the test, you don't go to high school. You go to learn how to farm or something. You know, that used to be how it was, but not anymore. Yeah, it's not like that, but there will be a branching off point where down the line you're gonna, one, decide where your interests are gonna take you, and two, decide where, well, I'll say two, decide where your aptitude's gonna take you, and then three, I guess, is a combination of those two things. And hopefully there's kind of a vergence of those two ideas, like what you like and what you're good at come together, and that leads you to a career. That's ideal. Sometimes people do what they like, even though they're not so good at it. That's not ideal, but at least they find fulfillment in it, right? At least for the short term. But anyway, so what'll happen is you'll get further down the line, and you'll have this whole series of mathematical skills at your disposal. All right. Then you start weeding out the ones that you don't need. All right, because you go into a certain field or you go down a certain route. Maybe you're a more science-minded person, in which case you're going to use all this stuff. More humanities-minded person, in which case you'll start weeding out some of the more technical things and focus on more of the practical things. All right, so at this point we keep things as general as possible so that you're ready for whatever thing you might choose to do down the line. All right, I can tell you that this technique for linear equations works really well for multivariable equations. All right, and if you're a computer science oriented person, you need to be able to work with more than two variables at a time. All right, so we have two variables here. This type of equation and this type of solution is very flexible when it comes to working with three or more variables. All right, so for the computer science folks in the class, this is gonna be very helpful down the line. So I gotta teach all the skills that anybody could ever possibly want to know, and then 2 years down the line, you're like, oh, I really didn't need that. Well, I really did need that. You know, then you start really kind of dialing in on it. All right. So anyway, that's my spiel on why we need to learn some of this stuff. All right. But anyway, find the LCM. So on Desmos, type in LCM, open parentheses, 3, 4, it tells you the LCM. All right. It's the beauty of Desmos. Odds are you just start typing in the thing that you're looking to find, and it's a command, because Desmos is math incarnate. You'll notice, and I've talked about this a few times already, but you'll notice it starts off in italics, but then once it locks in on an actual programmed command in Desmos, it turns to ordinary font. That's how you know you have something that works. All right, so 3 comma 4, you got your 12. So that's the number you're aiming for with these two values. So the LCM is 12. All right, and that's just assuming you didn't know it off the top of your head, because some of them are easy enough where you know it off the top of your head. If you know that the least common multiple is the smallest number that can be divided by evenly by the two numbers that you're interested in, then you're probably going to come up with 12 before too long. All right, I want to make these two numbers 12 through multiplication. So if I do that, I would multiply the first one by 4 and the second one by 3. All right, so you kind of notice a little bit of a shortcut here, but the LCM sort of gets you into why the shortcut works. One sec. So we need to make sure one of them's negative, because we'll get the 12 out of this. So 4 times 3 is 12, 3 times 4 is 12. If they're both positive, that doesn't do us any good. All right? That's where that last condition comes into play. One coefficient must be positive and the other must be negative, so we multiply one or more equation by a -1 as needed. So it's really just a question of which one you want to multiply by a -1. All right? Now, multiplying by a -1 is the same as just slapping a negative sign onto one of these two numbers. So pick the number you want to slap a negative onto. I'll do the first one. All right? So then distribute through with that, you get -12x minus 8y is equal to -16. You get 12x plus 21y is equal to 3. Now we're ready to rock and roll, because those two equations could be added together, and in doing so, we're going to cancel one of the variables. All right? One of those variables is gone. The x is going to go away. -12x plus 12x is 0. All right? We're going to get a 13y is equal to a -13. Property of equality, divide by the 13, and you get y is equal to -1. All right? So we have a solution now. I just need the other solution. It's just a matter of picking out one of the two original equations. Doesn't matter which one. I'm going to take the first one. I typically default to the first one and list. That's funny. Unless the second, just merged like 3 different words there. Unless the second equation looks significantly simpler than the first equation, I just latch on to the first one and go from there. All right. So 3x plus 2 times -1 is going to be equal to 4. All right, so 3x minus 2 is equal to 4. Again, and we're just popping in the -1 for the y. All right, add 2 to both sides. So 3x is equal to 6. Then I'm going to divide both sides by 3. And that'll give me my solution. All right, so I get x equals 2. Again, my solution is going to be 2 comma -1. All right, x comma y. All right, so 2 comma -1, x comma y. All right. So that's the most complicated one. Yeah.
How do you know on a test to use this method or the one that we did before?
They're going to tell you.
Oh, okay.
Yeah, it'll say using substitution or using elimination. If they say using any method, then you literally can use any method, even if you want to use a graphing approach. You know, so that should be the easy one.
Like, you'd be able to figure
I want to modify these two equations so that when I add them together, a variable cancels out. All right. Sometimes just adding the two equations together initially will make a variable cancel out. That's ideal. It doesn't always play out that way. It hardly ever plays out that way. But when it does, it's nice because you realize, oh, this one requires no work. All right. So you could always check that and see if that plays out. In fact, I'll check it right now. So don't write down what I'm about to write down. But what I mean by adding the two equations together is if you look at the two equations, you see that they're stacked by the like terms. So the x's are on top of each other, the y's are on top of each other, and the non-variable terms are on top of each other. Add those terms down the line. You'd get 15x, you get negative 5y, and you get 45. All right, this is no good, all right, which is why I told you not to write it down, because what I want to have happen is I want to have one of the variables cancel out. All right, that didn't happen here. All right, what we got to think about is how we can get the variables to cancel out, which is why this set of instructions is so frustrating, because it just says modify the two equations. All right, modify the two equations doesn't really tell you anything other than do something to the two equations to make one of the variables cancel out. Well, if the coefficients are opposite of one another, when I add them together, when I add the two equations together, I'll get a cancellation. All right, so let me take a look at just the x coefficients. All right, if these two coefficients, too many e's, two coefficients were opposite, then adding them would cause a cancellation. So that would be the ideal situation. Well, they're not opposites of one another. 5 is not opposite of 10. All right. But if I think about properties of equality, maybe I could multiply that 5 by something to make it the opposite of 10. Now, this is where the intuition comes into play. Now, there's a calculator approach that'll help us get this, but start with intuition, then resort to calculator. All right. Sometimes the intuition only comes after a lot of experience. So you don't have the instincts to get you to the right number initially. But then when you do like a bunch of problems, you're like, oh, I see a pattern here. It always tends to work out this way. Oh, I see it. All right. In this case, if I want to make the opposite of 10 out of a 5, I'm going to want to multiply by a negative 2. If I multiply by 2, it would make it a positive 10. That's close, but it's not opposite. That's exactly the same. All right, but by multiplying by a negative 2, I get negative 10x. See, I'd have to use my distributive property. Distribute through the whole equation. Leave my second equation alone because I didn't multiply that by anything. But now you can see my coefficients are opposites of one another. So if I add down the lines, negative 10x plus 10x goes to 0x. That negative y is the same as saying negative 1y. So 8y minus 1y, positive 7y. Negative 44 plus 23. So is that negative 21? I don't know why I'm blanking on that. Huh, maybe I'm not blanking on that. Look at that. Full disclosure, I did kind of blank on that, but I figured if it was going to be a clean answer, I knew it was going to be negative because the 44 was the negative one. So I knew the final answer was going to be negative, and if it was going to be clean, then it would have to be a multiple of 7. So I figured it had to be 21, so I just took a stab and I was right. So 7y is equal to negative 21. Divide.
How do you know if you're supposed to add or subtract all of them?
You always add.
Okay.
Yeah, and then the signs dictate how they combine. All right, so you're just combining like terms. So divide by 7, divide by 7. Division property of equality. You get y is equal to negative 3. And so we have the y value. Remember, with a system of equations, we need not only the y value, but we need the x value that goes along with it. But the rest of the problem is just like substitution. It's only the beginning steps that are different. All right? I could actually copy paste the steps from yesterday. Choose one of the two original equations. Replace y with a negative 3 and solve for x.
When you multiply by -2, is it always so you can get the same number but in the opposite like sign?
Exactly.
So what if like you can't multiply it by anything to get the same number?
We'll get to that in the next one. Yeah. It does get a little bit more complicated. But I'll show you the calculator trick for that. All right. So we're going to choose one of the first two, original two equations, what I meant to say. We have 5x minus 4y is equal to 22. That's one of them. Didn't matter which one I chose. I tend to go for the first one by default. And unless I look at the second one and say, oh, that one looks substantially easier. And unless it looks easier, I tend to go with the first one. So 5x minus 4 times negative 3, because that's what we discovered y is equivalent to. So 5x plus 12 is equal to 22. Properties of equality. Minus 12 minus 12. You have 5x is equal to 10. Divide. Another property of equality, get x equals 2. So now I have my solution. 2, negative 3. Always x first, then y. All right. Now, bear in mind, always something to keep in the back of your head, you have the calculator. All right. Whether it's the TI calculator or it's the Desmos calculator, you have the ability to check your work. All right. There's no reason why you should be doing all of this work without having a sense of what the answer should be, at least going in. So if you're doing it with Desmos, you type in your original equation, 5x minus 4y equals 22. 10x minus y is equal to 23. And see where they cross. 2, negative 3. We know the answer. We just have to make the algebra work. All right. But you can't ignore this technique because, and you know, I'm kind of, it's weird. It's kind of like a teacher approach to things. You know, I'm like giving you the business for the sins of your predecessors, meaning like the students who came before you in previous years. These are the mistakes that they made, and I'm treating you as if you've already made them. You've already made the same mistakes, even though you haven't done it. I'm hoping that by doing this, that I'll keep you from making those same mistakes. What students have done in the past is they said, I like substitution. I like that better. I'm just going to do it that way. And they just can't get out of their own head, and they're just saying, well, I'm just not going to do it this way because I like the other way better. And it's like, oh, cool, you like that way better. I'm glad that you shared what you like. And I really mean that. I'm not even being sarcastic. It's nice to know what people prefer, you know, because when it comes down to it, you know, that's good information for a teacher. However, you need to know both methods. All right, you're going to be tested on both methods. So it's not like you can say, oh, he's up there blah, blah, blahing about this example using this elimination method. I'm just going to do it the other way. I can promise you, you will get 0 credit, 0. No credit whatsoever if a question asks you to solve using the elimination method and you use the substitution method. All right. On the other hand, if you look at this, I mean, just a little bit more on the rare side. If you look at this method and say, oh, this is great, I love this method. I don't even like the one yesterday. Or more basic than that. I was absent yesterday. I didn't even learn that one. Oh, but this one looks fine. I won't even study that one. If a question says to use substitution and use elimination, you will not get any credit, even if you get the right answer. All right? So you got to be careful. These techniques are required. They're not optional. All right? So hopefully that's enough emphasis. I will emphasize it again and again and again before we take a test. We're not going to be taking a test next week, but in the following week, we'll be taking a test for systems of equations and inequalities. So we're getting closer and closer, but we're not quite there yet. But you got to be thinking about, all right, well, what's going to be on the test? Just like the last unit test, you'll have a practice test. You'll see what you're up against. So if you don't believe me now, you'll see on the practice test, using the method of elimination, solve the system of equations. Using the method of substitution, solve the system of equations. It's going to say that, I promise you. So don't neglect these concepts. All right. So now that was the quote-unquote easy case, all right, where it was just a matter of multiplying one equation by a number, and then you're good. So now let's look at number 3, where, I would love to get opposites here, but I can't multiply the 4 by a nice, clean, whole number and get a 5 as a result. I can multiply it by a fraction, but I don't really want to do that, all right? What you want to do, again, you can decide what variable you want to get rid of. Like in the first example, in number 2, we decided to get rid of the x variable. I could have got rid of the y variable. If I wanted to do that, I would have had to multiply by different coefficients, but it really is a matter of whatever you want to multiply by, or whatever you want to get rid of. So let's say in number 3, I want to get rid of the y's. All right, just for the heck of it. I'm going to use blue. All right, what I need is to create opposites out of this. All right, so I need these two numbers to be opposite of one another. There's I can't just multiply by a -1 and make that happen. All right, so I got to do something else. All right, so let me get you the process here. I just got to steal it from later on down the line. I wrote it out, and it's the benefit of copy paste, but also just general full-blown laziness on my part. All right. What you're going to do is find the LCM between the two coefficients. And I'll talk about how to do that in a minute, but for now we're just thinking about the process. Find the LCM between the two coefficients, and we multiply each equation by a value to make the coefficient into the LCM. All right. With the little caveat there that one coefficient has to be positive and the other has to be negative. So we multiply by -1 as needed. Right? I'll carry out the process in a sec, but that's the general idea behind it. Or at least strategy. All right? There's a couple of different ways to come up with the LCM. If you know what an LCM is, that's one of the ways. Sometimes just knowing the definition of a term gets you there. All right. LCM, least common multiple. That's the technique to use I can't even speak anymore. It's the end of the week and I'm just running out of steam, I guess. I don't know. Try that again. It's the technique that we use to find a least common denominator. All right, the LCM is the LC part of LCD. All right, so if that helps. If not, it's the smallest number that can be divided by the two given numbers. All right, so I have two numbers here, 3 and 2. I would want to be thinking about the smallest number that can be divided evenly by both 3 and 2. So you might look at it and say, okay, well, 6. Boom. But then other folks might be like, what do you mean, boom? I didn't get 6. How do you get 6? If you're one of those people, then you might want to use the technology to help you. All right? So there's no requirement that you figure it out in your head. Maybe in elementary school, middle school, there was a requirement, but not anymore. All right. So, in your calculator, Desmos calculator, Desmos calculator is easier because it's just, you just type in LCM. You see it starts off in italics, LC, and then once you type in the M, it goes from italics to ordinary font, which tells you, if you're familiar enough with Desmos, that it's a command that Desmos understands. So then open your parentheses, type in 3, 2, aka the two numbers that you want to find the LCM between, and you have it. All right. So let me show you on the TI. You know, in half an hour when the TI calculator opens up. Oh, there it is. Now, bearing in mind, and we've talked about this before, but I figured, I guess maybe on a monthly basis, I'll mention it again, at least until we get closer to the Regents. At some point, we'll have to transition to TI calculators, unless they change up how the Regents exam is going to happen. But I don't anticipate that happening. So, anyway, that's in math, the math menu. Over to NUM. And then you scroll down to the one that says LCM. All right, so for LCM, oops, I need a marker, I suppose. LCM on TI 84, math, NUM, and it is option 8. On Desmos, I mean, there's really no instruction there. You just type it in. You just type in the letters LCM. That one's easy. All right. But when you select that, when you hit enter on it, you type in 3, 2. The comma is right next to the parentheses. Close it up, hit enter, and it'll give you the 6. All right. So that's the important number. I said minimize. All right. That's the important number, which means that I want these two numbers to become 6. So I'd have to think about what I'd have to multiply each equation by in order to make that happen. However, multiplying and making them both equal to 6 doesn't make them opposites. It actually makes them the same. But you got to start somewhere. So if I want to make the 3 into a 6, I multiply by 2. If I want to make the 2 into a 6, I multiply by 3. But again, that'll make them exactly the same. If I want to make them opposites, I should multiply one of them by a -1 also. All right? But that's the same as just slapping a negative onto the number you're multiplying through. All right? I'm choosing to put the negative onto the first value, that -2. I could have put it onto the second one. It really didn't make a difference. All right? So what you get from this is a little bit of a shortcut. If you recognize it without me saying anything, that's great. If not, I'm going to say it anyway. But the idea is that if you can recognize these little shortcuts, then you're developing the number sense that you want to have moving forward. All right. If not, we'll get you there, but it might take a little longer. All right. So you may notice that for the first equation, we multiplied by the coefficient of the variable that I have highlighted in blue in the second equation. Yeah. In the second equation, we multiply by the coefficient in the first equation. All right, so if we always multiply by the coefficient in the other equation, that'll get us to our LCM. All right, we just have to manipulate the negatives and the positives. All right. So, I don't know if there's a good time to do this. I don't want to pause the recording, but I'm just going to say it real quick. Folks, for bathrooms, there's no reason why anybody should have to wait for me to finish talking. If you have to go to the bathroom, just hand up. I'll look at you, and then you just do a double point to the door. A double point to the door means that you need to go to the bathroom. It's just I don't want people to have to wait a half an hour for me to finish talking to ask to go to the bathroom. And also, with a recording, I mean, you don't want to end up on YouTube being like, I have to go to the bathroom, you know? Is that what you're going to? Yeah, double point. Yeah, that's all. That just means you need to go to the bathroom, and then I go like this, and then you go.
What's a 1?
What's that?
What's a 1 point?
A 1 point, I don't know. I hadn't thought that through. Maybe a 1 point is somebody's at the door. Yeah. Yeah, maybe that's what we'll go with. Double point will be like, I'm going to go to the bathroom. A 1 point will be, hey, there's somebody right there. You should look over that way. I don't know. I didn't really think that through. Just a double point seems to work. It gets my attention. It makes me think, oh, like emergency. You know, like I was thinking like the air traffic controller at the airport. You know, they're always waving. It's like urgent. You know, you got to get over. You know, like when somebody has to go to the bathroom, it's usually of an urgent variety. You know, so that's kind of where my mind takes me. That's all valid points. They didn't cover that in the American Sign Language class I took in college. They covered some stuff, but they didn't cover that. So, anyway, I'm going to multiply through with a -2. So you get negative 10x minus 6y is equal to -4. All right. For the second equation, I got a 12x plus 6y is equal to 30. And you'll notice now the coefficients of the y term are opposites, which is precisely what we had in mind. All right, so we're on the right track here. You just do a quick double check and make sure you distribute it correctly, because, I mean, anytime I screw this up, that's where I make the mistake. Not to say that you'll make the mistake, but never hurts to have a second look. And it looks good. So combine, you're adding down the lines. Combine, you get a 2x. You get a 26. Division property of equality. You get x is equal to 13. And then just like the substitution method, we snag one of the two original equations. Doesn't matter which one. I tend to default to the first one unless the second one looks substantially easier. I mean, they both look pretty hideous. So I'll take the first one again. So 5x plus 3y is equal to 2. I'm going to replace the x with a 13. So 5 times 13 plus 3y is equal to 2. So 65 plus 3y is equal to 2. I mean, this is some pretty crazy numbers, but still not too bad. I'm going to reduce the size a little bit so I can fit it. And I'm going to zoom in. So, little subtraction property of equality. Subtract off the 65. So we're looking at 3y is equal to negative 63. Divide by 3. Oops. And you get y is equal to negative 21. And so I have an x value, I have a y value. That's going to give me my solution, which is going to be 13 comma negative 21. All right, x value first, then y value. But I am going to compare that to the solution that the calculator gives me and make sure that I didn't just screw that up, especially since I see such crazy numbers here. I don't want to rest on the fact that I did all my algebra right, although I'm pretty confident about it. There's no reason not to check it. You have the means to check it, so check it. All right, so you look at the graph in the standard zoom, and you say, oh, there's no intersection there. All right, but if you zoom along, zoom out, scroll over, you see down over here there's an intersection, and that intersection, glasses keep fogging up. That intersection is at 13, negative 21, which is what we determined algebraically. So we're in really good shape. So we have a solution here. It's a valid solution. Now let me just show you very quickly how you can do this on the TI. It's not as pretty, and it's not really overly tailor-made for the elimination method. This is killing me here. So what we would actually have to do is solve the two equations for y in terms of x. So on the TI calculator, I actually wouldn't use it to evaluate a question like this in terms of the graph. So what we would do to check our work is actually fairly simple. All right, what you would do is just plug and chug and make sure it gives you a valid solution. All right, so let me just show you here. If you type in, let me keep it on the screen. Over here is fine, I guess. You type in the left side of the equation here, 5x plus 3y, but put in your x and put in your y. So 5 parentheses 13 plus 3 parentheses negative 21. That should give you the result of 2. All right? It's an equality, so the right-hand side should be equal to the left-hand side if x and y are true values. So by hitting enter, you should get a result of 2. All right? For the same values, so 4x plus 2y should give you a 10. So what I would do here on the TI is instead of retyping all this, I'd hit second followed by enter. It brings up the previous calculation. Then I'd hit the back arrow and overwrite the 5 with a 4 and overwrite the 3 with a 2. Go to the end and hit enter and verify that that gives a 10. All right, so if you're using a TI calculator, which not many folks are doing at this point, that's really for elimination, that's really all you would want to do. Because what'll happen is you'd spend too much time trying to solve your equation for y in terms of x. Like you would actually have to manipulate each of these equations to get y all by itself in order to type it into y equals here. It's not a practical approach. So the check on a TI calculator is typically by the numbers. All right. So I'm going to stop the. If you look at number 4. Again, if our goal when we're adding the two equations together is to get a cancellation of variables, if our goal is to do that, we want our coefficients to be opposites. So if I take a look at the coefficients of x and then in turn the coefficients of y, if I can identify opposites, then I'm already ahead of the game. All right? So the y coefficients are not opposites of one another, but the x ones are. So I don't need to make any adjustment to this whatsoever before I jump right into the process of adding the two equations together. All right. So x plus negative x, 0, cancels out. 5y is equal to negative 15. All right. So in one move, we're able to get from having two equations with two variables to a single equation with a single variable. All right, so this is the kind of question I was talking about before when I was saying that most of the time you're going to look at the system of equations and say, I don't want to do it with elimination. I'd rather use substitution. But every now and then you'll come across a problem or two where you say, oh, this is perfect. It's tailor-made for elimination. This is one of those. If it's a case where you can just add them together, or if it's a case where maybe it's a very slight adjustment that you need to make that allows you to cancel out a variable, that puts you in a pretty good spot. So here I would divide by the 5. And when I do that, I get y equals negative 3. So again, choose what you deem to be the easier of the two equations, but if they look roughly the same, just grab the first one that you see, which usually is the first one. Swap out the variable you just solved for its known value. Simplify. 3 times negative 3 is negative 9. X plus negative 9 is really the same as x minus 9. Addition property of equality. We can add a 9 to both sides. and you get x is equal to 2. So my solution, 2 comma negative 3. All right, so I would actually say that you'd probably be able to get this one done quicker than you would have been able to do it using substitution. All right, so again, just a quick double check. X plus 3y is equal to negative 7. Negative x plus 2y is equal to negative 8. Tap on that intersection and it looks pretty good. All right. So then looking at number 5, again, you have a choice. You diagnose, you take a look and you say, all right, I got my two variables. I have my x variable, I have my y variable. I want to determine which one is it going to be easier to cancel out. Is it going to be easier to cancel out the x's? Is it going to be easier to cancel out the y's? We want to be looking for opposites. All right. In the case of the y's, you'd have a little bit of work ahead of you with LCMs and stuff like that. But in the case of the x's, it really is just a simple matter of multiplying the first equation by a negative 2. Because if I multiply the first equation by negative 2, I get that coefficient to become a negative 2, which is the exact opposite of the leading coefficient in the second equation. All right. So multiply by negative 2, you get negative 2x minus 6y is equal to 28. The second equation, just leave as is. And you see it's, again, another situation where the two variables will cancel out when you add the two equations together. If you get to this step and you're noticing that they're not opposites, then you're choosing the wrong number to multiply by. All right? But that might be a quick fix, because if you get, let's say, for example, you get this, but without the minus sign there, then you'd say, oh, I'm just off by a negative. So instead of multiplying by a 2, I'd multiply by a negative 2. You know, it could be just a quick sight adjustment. All right, but we have a nice cancellation here. These two will zap away. Negative 6 minus 4 is negative 10. So negative 10y is equal to, this is going to be a 60. See, again, down to one equation with one variable. All right, so I want to get the y alone, division property of equality, divide by the negative 10, and I get y is equal to negative 6. All right. So I have my y value. I need the corresponding value of x. Just a simple matter of choosing one of the two equations. So whichever one you like. The first one actually in this case looks a little simpler than the second one. But we'd have x plus 3y is equal to negative 14. I'd be replacing my y with a negative 6. So x plus 3 times negative 6 so x minus 18 is equal to negative 14. Add the 18 to both sides and you get x is equal to 4. All right, so solution 4 negative 6. Again, you don't want to do all this work without checking it. So right into Desmos. Now, recommendation, if you want to have a user-friendly way of checking your work, you might want to put your Desmos together in a more general form. All right, so in this case, we could type in the x plus 3y equals negative 14 and 2x minus 4y is equal to 32. Get your solution that way. But another way you could do it is to put little coefficients in here like an a and create a slider and stuff like that. All right. But I wanted to do one more in the last couple of minutes that we have, because you see that there are some situations where you kind of look at the problem and you think it might be more tailor-made for substitution, especially since you have y value, x value that are pretty close to being alone. So just one last one to go through. Again, still, even though it looks like it might be more tailor-made for substitution, it's just a matter of multiplying by -2. You get -2y plus 6x is equal to -22. So it doesn't matter what order the variables are in, as long as they're what we call stacked. So the appropriate variables need to be on top of one another. So y over y, x over x, constant over constant. All right, so I'd have 2y minus x is equal to 2. All right. Now, I'm almost done with the problem, folks. You can just hang on for a sec. So 0 is what you get here. So 5x would be equal to -20. Divide both sides by 5. And you get x is equal to -4. All right, so again, choose one of the two equations. You see it goes much quicker now. Replace the x with the variable's solution. So y minus 3 times -4 is equal to 11. So y plus 12 is equal to 11. Subtraction property of equality. Y is equal to a -1. And so we have our solution of -4, -1. All right. And so, you know, this is a nice wide variety of different possible problems that you can focus on. And in fact, I did a good chunk of them for you. So you're only on the hook for, you know, just a few more problems, really. There's a video posted for definitely number 3 on page 15. And there's a video posted, I believe, for number 6 on page 14. So if you need more explanations for some of these, but this is a good amount of problems that you'll have access to. All right. So definitely take the time to review this on your own.